Hey everybody. We're gonna go ahead and move into our outer planets now. The previous video we did talk about inner planets, so if you have questions on it, ask. If you did not watch it, you need to watch that first. Do not watch this video until you watch that video and fill out your inner planet notes. So if you've done all that, now you can move into the outer planets. Remember on, I'm gonna pull it up. Remember on your notebook for this section, I gotta scroll over. I think it's kind of just being crazy. But anyways, we're going to fill in the stuff on the Galilean moons, which is in the middle. And then we're going to fill in the 4 outer planets and characteristics of the outer planets, alrighty? So our 4 outer planets, and I'm pulling this up from a previous little slideshow. Our 4 outer planets are Jupiter, Saturn. I know we all joke about the pronunciation of Uranus, but I've heard many people say both, either Uranus or Uranus. So yeah, and then Neptune. These planets have a nickname. They're the gas giants because they are composed of gas. That means if we were able to travel there, which we are not, but if we're able to travel there, you would go there and fall through the planet. It is composed of gases, alrighty? They're going to be way larger than the inner planets, and they're separated from the inner planets by the asteroid belt. So if you notice, like this is a little side-by-side little thing here, and I can even zoom in more. Maybe I should do 200. I don't know. Oh no, we'll go back to 100. It was kind of big. So if you kind of see Mercury, Venus, Earth, and Mars are like itty bitty compared to these ones. All right. And then right in between here would be like the asteroid belt. And then you have the Oort cloud like way out here. But you can kind of see Pluto is a dwarf planet. He's way over here. So look at Pluto compared to Jupiter. That's insane. Or this one's Pluto, sorry. And then you have all the other little dwarf planets here just compared to Jupiter. That's really crazy. But we're going to go into these planets and start talking about them. The notes you'll fill in, you could even like literally at this point, pause the video right now, and you could fill in right here and pause the video and fill out your characteristics of the outer planets. And then you could kind of, when you're done, scroll over, pause, and then fill out the characteristics of Jupiter. So you could do that part. And then like pause the video and then continue, and I'll start talking about it. So I'm going to go to the planet Jupiter. Remember, Jupiter has like that great red spot on it, and that great red spot is a big storm, kind of like hurricane-esque dust storm kind of thing. And you can fit 2 Earths inside just that storm. The whole planet of Jupiter, you could fit about, I don't know if it's over, but it's close to 1,000 Earths just inside Jupiter. And that's crazy. I don't even have a better word for that, but it's insane that you could fit 1,000 Earths into the planet Jupiter, and that's how big it is. So with this planet, it is the largest one. Like Jupiter is the big kahuna. Jupiter is also going to have many moons. On this other slideshow that I have, it even kind of talks about it more in depth. You can kind of see that it has roughly 62 moons, one of which has been in the news recently, and they say that moon, I forget what the name is, nothing you really need to know, but that, just a little bit of extra information, that moon could possibly have like water on it, meaning it could possibly have life on there because those moons are rocky, meaning you could travel there if we were able to and stand on them. So that's kind of interesting what's out there. But anyways, for it to go around the sun one time, one revolution, it takes 12 Earth years. So that's another really insane kind of tidbit. There's going to be, of those 62 moons, there's 4 Galilean moons for Jupiter. So if we go back to your notebook, in the center here, you might want to like pause here and there. You can kind of see the section about the Galilean moons. So I don't really know the exact pronunciation of these, but Io is the most inner moon to Jupiter. It's driest and most geologically active. So you can fill in these notes about the Galilean moons. They are called that because they were discovered by Galileo Galilei back in like the 1600s, I believe. But that's the astronomer that found them. And this planet, and again, you want to make sure you pause and fill this in because we are currently in the process of thinking about a test for you guys just with questions from your notes. All right, so if you have the notebook filled in, you have an open note test. If you don't, that's too bad. But anyways, this planet's made mostly of 90% hydrogen and helium. So these planets, though, do have a solid core. So you wouldn't exactly fall right through them unless you were like off to the side, but the core in the middle is solid. The outer, everything else is going to be gas. Alrighty. So now we can move into Saturn. And to tell you a little bit about Saturn, we talked about planets being dense. Now the gas giants are going to be made of gases, so they're going to be less dense than the inner planets. But Saturn is so light and it's less dense than water, meaning if there was like a bathtub or a pool big enough to hold Saturn would float. It's that light. So that planet could actually float. Its rings are like Saturn has really pretty rings, but its rings are made up of like particles from space, meaning dust, ice, rock, little bits and pieces of that. So it's not as pretty as what you think, but it's really cool. I mean, recently, I don't know if any of you saw the Christmas star. You could actually, at one point, I believe, see Saturn in the sky. I didn't get a chance to see it, but I heard it was pretty cool, and I saw pictures on the news and whatnot. So, again, these planets are going to be very cold. Saturn does roughly, again, this one has about 62 moons as well, so that's crazy. We have one. They have 62. It takes 29 years to go around the sun, 29 Earth years to go around the sun. This planet will have the most moons in our solar system, though. They're both around 62. I just don't know the exact numbers, and all you need to know is like it's multiple digits like that. It's a negative 170 degrees Celsius. Back on the other slideshow, just to tell you a little bit about Saturn. I did tell you about all this, and has many rings. So, you know, Saturn's a pretty cool little one. So if I meant to go back to that slide. Sorry. All right, go up, Miss Mask. Go back over here. Alrighty. So when it comes to Saturn, these are the notes. So you might want to pause now and fill in your notes. Okay. The next planet we're going to go into is Uranus, or Uranus, however you want to pronounce it. And you can kind of see it's really pretty blue on this planet. I will give you a little bit of a heads up about Uranus. It takes 84 Earth years to go around the sun one time. Now, all the planets have like that axis that they spin on, and they're all a certain degree tilt. Uranus is actually that one that spins on its side. And let me pull up a picture to show you. So hold on. Alright, so in this picture, you guys can see that the degree of tilt that each planet spins on its axis, like this is Earth. So you can kind of see compared to the other ones, the way it turns, and the degree of the tilt. Okay? When we get to the gas giants, you kind of see they're all like, Jupiter isn't really that tilted, Saturn's more tilted, like us, I guess. Yeah, so is Neptune. But when you get to Uranus, it's spinning on its side. And there's all these old stories about how a planet or whatever knocked it on its side. But in general, Uranus is going to spin on its legit side and kind of spin up and down rather than like left to right or right to left. So that is very interesting and kind of a weird little tidbit about Uranus there. So again, we're going to go to that slide. It has about 27 moons. It is a really pretty blue-green color. I think that previous slideshow does a really nice depiction of it. Now, when it says, whenever you guys hear about things, like I'll tell you about Pluto and stuff, but whenever you hear about things about Uranus and other planets with satellites passing by them, kids in the past have thought that this meant like an actual people were on here and passed by Uranus. No, people cannot, since it takes so long to get there, there's no possible way. I mean, we're still trying to figure out how to get to Mars. We cannot go to Uranus. But we can send satellites. But it does take a long time for these satellites to get to these places. So it can take years upon years upon years to get there. But they're going there, they're taking pictures of its surface and atmosphere to give us a better idea of what that planet, what's there, and what could be beyond the solar system. There's even been the discovery a few years ago about the exoplanets. If we have time, I might tell you about those ones. But how scientists discover these things, they look at light. They see how stars are reflecting. Like all those stars out there, those are technically suns in other universes out there. Like we're in the Milky Way universe. Other stars you see at night are suns, really far away. It kind of takes me back to the scene from The Lion King where Timon was like correcting Pumbaa, and Pumbaa was actually right. And he's like, they're planets, or not planets, but you know, those twinkling lights in the sky. Timon was telling them like they're fireflies or whatever. And it kind of makes me chuckle because this is pretty much what we're talking about, is that those stars are suns in different universes. And it's really, I just think the solar system is a really cool topic. But anyways, a little tidbit about Uranus is that it actually has 13 sets of rings, but they're like invisible. So just note that Saturn's not the only planet with rings, but it's the only one with visible rings that make it look kind of cool and pretty. Uranus does have rings, but you can't really see them at all. The thing about Uranus that is so neat is that I heard on the Science Channel this one time is that it has like that methane in its atmosphere that does make it look blue and green. I don't really know the exact process, and you don't need to know this either, but through chemical changes that happen on that planet, like hydrogen is with helium, it makes methane, and in that process, it can, in certain areas, it rains diamonds on Uranus, and that's like so cool to me. All the kids are always like, we want to go there, we should just live there, blah, blah, blah. But, yeah, so just kind of letting you know, 84 years to orbit the sun. It's a really cool planet. If you head back to the solar system notes, the key, you might want to pause at this point and jot down these notes, alrighty? Because then we'll move on to our last planet of Neptune. And Neptune is super blue. It is like almost bottom of the ocean blue kind of prettiness. Neptune takes 165 Earth years to go around the sun one time. Voyager 2, that same one from the Uranus slide, also passed by it. And this planet also has a great spot. That was Jupiter. It has a great dark spot. This area here that similar to Jupiter's great red spot. It's a big storm, like hurricane-esque. And I guess what I had heard is that at one point it disappeared. I don't remember what time in history, but it had disappeared. And then a new one brewed. So that's kind of the cool little tidbit about Neptune. But that storm is scary. If you've ever seen pictures of hurricanes, just imagine like 10 times that. It's crazy. But yes, Neptune is going to be smaller than Uranus, but it has a greater mass, all right? Meaning, remember, mass and volume, when we talk about mass, it's how much matter makes up an object. So, back to that other slideshow, just kind of letting you know, Neptune does have 13 moons. The atmosphere is going to be mostly hydrogen and helium. Like, we can't live there, we can't go there, we die. It's going to be a negative 210 degrees Celsius. Okay, so just kind of giving you guys an idea about these planets. Remember, they're all gas giants. We'd fall pretty much through them, but the cores are all going to be solid on these planets. So on your notes, make sure you pause and fill this in. Alrighty, and don't forget the notes in the center. You want to make sure you fill in these notes about the Galilean moons. And then when we get there, we'll fill in this side about gravity. I mean, you can fill it in now if you want, but gravity is going to be a big topic this unit. So just note that'll be a future video and future activity, okay? So we're not there just yet, but we will get these filled in over on the side. So yeah, that's pretty much it.